Good evening. Welcome. Thank you for staying late for this live framework session. I'm going to assert that everybody here is an end user of services and software. Sure, we're all developers, but we're also end users. And as end users, our expectations are growing greatly. So today, we expect our data to be available anywhere. This is on any device, any location. This means your photos should be on your home PC, your work PC, available through a browser at a friend's house or on your mobile phone. And it's not just data, it's applications too. You want to be productive with your data. You want to be on an airplane at 30,000 feet, and you want to be able to take an action, like update your social profile or annotate a photo. At the same time, you'd also like to be able to share this data with any of your friends. You'd like to be able to share it in a consistent fashion to leverage the contacts and address book that you've already built up. And you want to be comfortable with the way you're sharing it so that you don't have to give away your password. You want to make sure that it's scoped to the application or the user that you've given them to. And finally, you don't just want to share data, you also want to share applications. You want to be able to share an experience with other users. You want your websites to be able to synchronize photos or playlists back to whatever the site of your choice is. You want rich client applications to be able to take advantage of the data that's in the cloud. You don't want your data to be siloed. That's the key. So finally, as developers, this is a lot for us to live up to. It's a tall order to deliver experiences that meet all of those expectations. So the live framework is a bridge between your applications and the power of the live services that will help you enable those scenarios. So my name's Raymond Endres. I'm a development manager at Microsoft. And today, we're going to drill into the live framework. For the next 60 minutes, we're going to look at the framework as a whole. We're going to talk about the API kits, or client libraries, if that's more familiar to you. And then we're going to spend most of our time on the managed API kit. So if you go away with just 3 things today about the live framework, this is what we'd like you to know. First, the live framework, abbreviated LiveFX here, is the uniform way to program all of the live services. This means from any device, any platform, any programming language, or any application, you have access to the power of live services. There's a complete, comprehensive, and coherent resource model that's exposed through the live framework to make it easy for you to navigate all of those services. Second, the live framework helps bridge the benefits of software plus services, giving you the benefits of both. And finally, there's a great .NET API kit available today. So if you're a .NET developer, you can start taking advantage of this now. So by now, I am sure you've seen the Azure Services Platform slide many times. Live services is one building block set of services in the second tier there. We'll drill into that one. This is the set of user-centric services. So live services are composed of quite a number of independent, scalable, and secure services. One of those bases is identity. This helps you manage the identity for users, applications, and devices. There's a complete directory. This enables you to manage associations and relationships between those principals. There's scalable storage for storing metadata and blobs. There's a complete communications and presence infrastructure. It includes a rich pub/sub notification system that I'll talk about more later. There are complementary services like search and geospatial. And above that, you have a set of mesh services. These mesh services have a distinct user focus. This helps the user manage their set of devices, their set of applications, and their set of data. All of these are synchronized. So not just your data, but the applications that utilize that data can be synchronized across the devices. Any context can be synchronized across those devices. So now the live framework gives developers a few things. First, it helps them span the cloud, the client, and the device. It does this by providing a symmetric API, an HTTP endpoint, on both client and cloud. Second, it provides access to user data, everything from contacts to photos to files. Going forward, we'll expand the number of resource types that are available through the Live framework. Finally, there's a rich ecosystem for applications. In the user's mesh, you can host an application. This will be distributed across the set of users' devices. That user can share this application with other users. This helps with the viral spread of applications. There's a news event system for when users install new applications or take action on the data they're in. And of course, this is easy to get started. There are API kits available so that it's natural for you to program in whatever language or environment you know today. And because this is built on open protocols, we expect that there will be more API kits as we move forward. So there's quite a range of ways to integrate the Live framework into your applications. You can think of applications on a continuum, from reach applications, web apps on one side, to rich client apps on the other. In between, you have these hybrid applications that we call mesh-enabled applications. These are web apps that you can take offline, and there'll be a talk tomorrow on that in more detail. From a web application, you can do something as simple as fetch a user's contacts to be able to present them with a simple address book so that they could share data or invite their friends to some event. You could dive in further, and you could start to synchronize photos so that your two photo sharing services worked well together and the data was the same. For a rich client application, users typically work on multiple PCs. It would be nice if your application could take advantage of the user's mesh and the Live framework to synchronize files or settings across those devices so that your customer had a better experience across the range of devices. It would also help you take advantage of news systems so you could generate events that were published into the user's social profile. In general, the Live framework is very open and flexible. You can opt into as much as you want or as little as you want. So the Live framework is composed of a number of major components. At the base in green, we have the Live operating environment. This is effectively the set of runtimes that expose all of the functionality for the Live services. There's a symmetric runtime on both client, cloud, and device. This runtime exposes an HTTP endpoint. This is accessible through common protocols like AtomPub and FeedSync, and exposes a very consistent set of resources. So if you're a rich client developer, you can program against the Live operating environment on the client, and that's available to you offline. If you're a web developer, you can program against the one in the cloud. Now the resource model. This is what's served from that runtime. There are a whole set of core resources, like identity and devices and applications. There's all the specific user data, like photos and files and contacts and calendar events. There's the communications infrastructure that helps you establish device-to-device communications, device-to-device synchronization, and application-to-application synchronization. There's also the application model itself, where you can bundle up your mesh-enabled web application and have that hosted and distributed across a range of devices. These resources are available in the format that you choose. So if you're a web developer, JSON may be the most obvious example and the easiest to integrate. If you are a web service, you might prefer these in Atom or in POX. All are available. They're consistent across the resources. The protocols that are exposed are AtomPub and FeedSync. Through these, you have a way to either perform simple CRUD operations against each of the resources, or you can synchronize with your own database. And finally, the set of operations is as consistent as possible across the resources exposed from all of the services. Now, to make these easy to use, we provide a set of libraries, client libraries, that sit on top of this resource model. So today, we have the full CLR API kit, we have a Silverlight API kit, and we have a JavaScript API kit. Going forward, we expect the community will provide more, we will provide more. We'll also build some higher level pieces so that it's easier to integrate the low level resources with your presentation layers. Like all good Microsoft platforms, there are a set of tools and services that support the live framework. So there's a developer portal. This is where you can do account provisioning and analytics and manage your application. There's Visual Studio templates to help you build new applications easily. This is the exploded version. I don't want to talk about all the details here. We have some fancy posters that are available afterwards that are even in nicer form than this. I invite you to dig into those and explore the depth of functionality available in the live framework. So I'd like to show a simple application based on the live framework. So Meshboard is a private message board. This is an ASP.NET app. We'll create one today titled PDC. What keynote sessions, keynote demos did you like? What this is doing is creating a new message board that's being represented as a resource in the live framework. So it's published and then synchronized across all of a user's devices. That first post is a data entry. No. This is a second page. It's now showing me that there's one post in this new message board. That post is a data entry inside of this object. This is now available on the client because it's been synchronized across my devices. If I choose to add another member, I can select someone from my contact list, and I can invite them. And say welcome. So what makes it more interesting is if we now go we're going to run a WPF version of the same application that talks to the client, looks at the same data, and shows you the list of message boards. So now we can see that we have a new PDC message board. So on its own, this isn't a very compelling application, but it's the basis for a scenario that you can build into something more exciting. You could start to integrate the user's social profile, so you can add pictures and current events. You could start to make it more collaborative by enabling users to post more information, what they're working on, progress for how they're tracking. You could enable this as a mesh-enabled web application. So you can take that WPF code, you can wrap it up as a Silverlight application, and you can publish that into the mesh. Now this is available for you to manage and update whenever you like. We'll go through the code for this and show you how to expand it in the rest of the talk. So I mentioned earlier, there are a few sets of client libraries. The .NET 3.5 client libraries, that's what the WPF application used. The Silverlight APIs, so those will be used tomorrow. There's a talk about mesh-enabled web applications that use these heavily. The JavaScript APIs. The JavaScript library that we ship as part of the SDK is literally what the web desktop that we ship as part of Live Mesh is built upon. And then you can have client controls and web controls that help with the data binding of the presentation layer to the underlying mesh resources. So now, the .NET API Kit in particular had a few design goals. We wanted to make sure that all the resources that were exposed from the live services were cohesive and consistent. This means that when you update a photo, there's a contact. You can navigate to that contact. When you look at that contact, you can easily go find their profile. From that profile, you can navigate files that they've shared. So the resources are meant to tie closely together. Second, we wanted to make it as natural as possible for you to use this if you were already familiar with .NET. This means that your async patterns and your data binding are the same as they were in the past. And finally, we wanted to make sure that we offered a symmetric programming model between client and cloud to give you the benefits of working offline and working on a range of devices. So the resource model, the set of resources exposed by the live operating environment, starts with a data entry. This is the base unit of storage, of extensible storage for application developers. You could think of this as an item in a grocery list, or you could think of it as a blob, a media entry. Both of these will be synchronized across the mesh. If you have multiple data entries, you can loosely associate these, but there's no transaction spanning them. Data entries are part of feeds. That's just a representation, a collection of items that you're going to update independently. So when you looked at the message board before, your messages posted in that message board were items in this feed. So mesh objects are an interesting notion. These are the container for data that is replicated across a user's devices. It's also the unit of permissioning to share with other users. So while the data is stored in data feeds, and there can be multiple of them within a mesh object, the mesh object is really the container, the administrative container. At the same level as the data feeds, for extensible data, you have a few other important types. So first is a feed of members. Who is this data being shared with? And what role do they have? Second, what are the mappings? So which devices does this data appear on? The user can select that. The applications can select that. News is scoped, in this case, to the mesh object. What events have happened, either user-generated or application-generated? And finally, subscription. There's an efficient pub/sub mechanism to enable you to subscribe to changes within this mesh object, either locally or in the cloud. So the mesh objects are rooted in the mesh resource. Peers to that are, from the user's point of view, the devices, the applications they've chosen to install, the aggregated news across all of their resources, and the notification queues describing what's changing. So in addition to the mesh, the live framework has a few other top-level resources. The set of contacts that a user has, the set of profiles that the user has. They can have multiple profiles. And there's a script entry point. This is an interesting one. There's a detailed talk tomorrow morning that goes into it. But if you're operating with an HTTP endpoint, particularly a RESTful one, they tend to be fairly chatty. And so you want to batch up operations. And it's nice if it's not just a simple batch, but if there's a conditional flow in the batch, or there's a way to data bind results from one step to the next so that you can execute a great number of operations in a single request. So for a moment, I'd like to drill into what these feeds actually look like. So if you're not familiar with the live desktop that is available through Live Mesh today, this is one of the applications within that Ajax desktop. It's a folder browser. It's meant to look like the Vista folder browser. In it, you have a collection of files and folders. On the side, you have a mesh bar. It shows news, members who've joined, files that have changed. You have a list of members, and then you have the devices to which it's synchronized. This UI is literally built on top of the JavaScript API library that we ship in the SDK, and all of these visual elements are represented directly in the feeds in the resource model. So this is a tool called the Resource Browser. It's a simple utility that simple utility that allows you to explore the feeds that are available through the service. I wrote this about a year ago as we were debugging Live Mesh. It was helpful to be able to see the resources and click around. When applications were having problems, you could actually look at how they were representing their data. So I expect it'll be a useful tool for people to poke around and see how other applications represent their data in the user's mesh. If you're familiar with AtomPub, you'll notice this is a service document. This is the root of all the Live Framework resources. As we saw in the diagram, the mesh is a peer of scripts and profiles and contacts. Within the mesh, you have your set of resources. If we were to go look at mesh objects, this entry, is the PDC mesh object. This has a type of live mesh folder. That's the only thing that makes it special so that it shows up in the UI. And in it, it contains several feeds. The data feeds, this shows literally entries for the files and folders that are available. Those are enumerated and rendered in the UI. The members, who it's sharing, and the mappings to which devices. So if we were to drill into members, we'll see that there's 2 members, just as in the UI. So there's one application that's built on top of the resource model. Message board's another, and we look forward to feedback from you on how to build others and how to expand the framework to make it easier to build your applications on top of it. The live operating environment class is the main entry point for all access to the runtimes, cloud runtime or client runtime. You're going to load this class and establish a connection to it, and from that, you can start operating with all of the resources. So it offers the standard sync and async patterns that you're used to, and you can establish local or remote connections from the runtime no matter where you are. Additionally, there are a few options that are useful. There's a prefetching policy that you can control to see how chatty, or sorry, to set how chatty this is and how much data is pulled down. I'll save the code until we go through in Visual Studio. So early on, we mentioned that it's really important that users are in control of their data. So we took this to heart in how we access data in the mesh. Rich applications are working on behalf of users. When a user installs a rich application, they're making a trust decision about that application, and therefore they have access to all of the data that's available through that endpoint. Web applications, on the other hand, require delegated auth to access the data. This means that they have a scoped access to the data. They may have access to a single live mesh folder or only to the contacts. Mesh-enabled web apps are sandboxed, both client and cloud, and again, they use delegated authentication. The flow for delegated auth is fairly straightforward for a web application. The user is viewing some third-party site. They initiate an action, like wanting to invite a user, that requires access to their data. At that point, the website will redirect to a consent page on the live site. The live site will list the request that the third-party website has made, for instance, enumerating contacts. The user has the option to approve or deny that. If the user approves, the web browser redirects the user back, and there's a delegation auth token that's included. The third-party website can then use that delegated auth token for all subsequent calls to the live framework APIs. Now, at some point, these time out, and they need to be renewed, but there's a standard way to do that as well. So we're going to step through a really simple application that shows a few different ways of connecting to that runtime. So typically, things like your username, password, et cetera, will be pulled out of some secure storage. For here, we're going to load them out of a config file. So the first thing we're going to do is enumerate the mesh objects of type live folder from the local endpoint. So we're going to create a new instance of the live operating environment. We're going to connect to the local instance. This assumes that that is running. And now we're going to enumerate all the mesh objects. And we're going to check their type. And not all of them will be live folders. In this case, Meshboard also created a mesh object. If we skip ahead, we'll see that it enumerated 2 mesh folders. And this parallels what you saw in the live desktop. There was one named Sample and one named Contoso. So now we'd like to establish a remote connection. In this case, we're going to do this with full trust. We're going to pass the username, the password, and the endpoint that we're going to talk to. And this is a CTP endpoint. So the endpoint here is user-ctp.windows.net. We'll connect. I didn't disable prefetching in this case, so the connect takes a little bit longer because it pulled a few of the top-level resources at the same time. Again, we'll enumerate through all the mesh objects. And what we've seen is they've been enumerated, this time in a different order. The order wasn't guaranteed. We didn't specify a sort when we did that. And finally, I want to show the delegated authentication. So also in that config file, I have a delauth token that was created via the redirect process. And as a user, I only granted permission to the samples folder. I'm going to specify live item access options false. This basically says don't pre-cache. We'll connect. Since we haven't pre-cached any of the resources, we do need to load the mesh objects so we can enumerate through them. I'm going to call the synchronous method here. Now we'll loop through. We'll see one, and I went too fast. The reason you only saw one is that the request for all of those feeds only returned the one you had permission to. And so it is the one sample. If we look at this, there's no Contoso. So that's scoped access to a user's data. So a mesh object, as I mentioned, is the container for all of the application data. It's the unit of extensibility. It's the unit of synchronization across devices and across users. It's the unit of sharing. The user has a choice of which devices they want to sync this data to, and applications can also specify that through the mappings feed if it's required. In addition to the data feeds and the members that we've talked about, the activities feed is a new one. This is for transient notifications. So if you wanted to publish, say, your location or what you're doing at this moment, it's an efficient way to do that and have that transmitted through the mesh object. The sample below we'll look at in more detail in a moment, but effectively it's showing a mesh object is a typical C# class. Poker chip is a second class. This is data that we want to persist at the root of the mesh object. Maybe it's a poker game that we're trying to create. There's a set user data function which will serialize that data for you and insert that into the content section of a resource. Now in the feeds, they support both metadata and blobs. They have full replication capability. You can CRUD feeds at any time. This means when you're offline, you can still create, read, update, delete items, and the conflicts are available to you later on to resolve as you wish. There's a way to subscribe to changes in the feed so that you can efficiently update your view of what that feed is. And a mesh object can have any number of feeds. This is useful for a few reasons. If you have different components in your application, you can isolate them and have their data stored separately. If you want to have multiple applications work in the same mesh object, they can store their data independently. So if we look at the meshboard application itself, we're going to look at the page, which is simply a list of all of the mesh objects of type meshboard. So what you'll see on the ASP page would be no surprise. You have a grid view at the base. It's showing you the UI. It's templatized in this case to be friendly. It's bound to an object data source. So for the purposes of this application, we have a simple object data source that we'll walk through and show you how to enumerate the resources. As part of the SDK going forward, we'll build a live data source that will do a lot of this more efficiently and expose those for you so you wouldn't do this yourself. If we look at that object data source, it's literally connecting to an object called meshboard in here, and this has a method on it called getAllMeshboards that takes as a parameter a live operating environment. Let's go look at what that does. So this is the method that is data bound to the select of the grid view. The first thing it's doing is looking to see if the mesh objects are loaded. It's loading them if they're not. It's doing this synchronously. If you're building a scalable website, I wouldn't recommend this is the pattern. We can do that a lot more efficiently, and we can not block the page rendering thread. Then it builds an observable collection, and it populates that collection with the results of a query. So it's useful to use queries in general here because you can start to push some of the filtering off to the cloud. You can effectively use URI link to send a query from your website or your application up to the cloud and pull down a subset of that data that you would then render in the UI. And so finally, we're going to take the results of the query and we're going to add them to the observable collection, and that's all that's rendered on the screen. Now when you create an application, it's a little more interesting. So there are two operations that need to happen to create a brand new message board. The first is that you're going to create a mesh object with some title that the user selected. The second is that you're going to set the type to meshboard. This is so that you can identify it later when you're filtering out your resources. You're going to add that new object to the list of mesh objects through the live operating environment variable. But you're also going to define your first data feed because that's where you need to store your data. And you're going to add that data feed to the list of data feeds that are part of a mesh object. So here we have the new data feed class. We set a type for it as well. This way, if someone extends this mesh object, we can still find our feed. That's good. So sharing is not quite as simple as you might first think. You don't blindly add another member to a mesh object. You need their permission if you're going to share with them. So in this case, a member is represented by their live ID, and there's a resource, a member resource, that gives you some information about them, and that's enumerated with the mesh object. But what you're really going to do is invite that user, and you do that by posting a pending member, effectively, with an invitation. The infrastructure sends an email invitation today. It can be a different transport in the future, but the user accepts that before they show up as a full member of the resource and before it starts synchronizing to their devices. When you invite someone, there's a role associated with it. It's full, reader, or writer. Full is simply writer plus the ability to invite new members. Once you start inviting new members, the chance of conflicts goes up. So you certainly had conflicts in the single user case across multiple machines, but once you invite other users, it goes up a lot more. FeedSync is the underlying synchronization protocol that's used for all of the live framework resources. So FeedSync is a very lightweight set of extensions to Atom and RSS. It supports multi-master synchronization. The full version history is retained, and this enables you to present as much information as necessary when you're resolving conflicts for users. So you can do something as simple as last writer wins. You can have a heuristic to determine who wins, or sorry, how to resolve the conflict, or you can present that question to the user. So FeedSync is licensed under Creative Commons. Any endpoint can implement this. There's a JavaScript example, I believe, up today on the feedsync.org site. let's look at the code for actually inviting a user. So within the invite page, what happened is that you would select multiple users. Those users would be batched up, and then an API call would be made. This method here, add members, was that API call. And so this is the list of members that they would like to invite. Some invitation text that was sent in the UI. I said a simple welcome earlier to the PDC message board. So the first thing that the object is doing in this case, the data object, is finding the right message board and then issuing an add member and send invitation call. So this is the interesting one. We're going to create a new member resource. We're going to fill in the member name and the member email. We're going to assign it a role. In addition to that, we're going to create an invitation resource. You set an expiration for this, and this is where you set we set it later. This is where you set the invitation text as well. You bind these together, and then when you're done, you post this to the members feed. At that point, this will if you've done this locally, that will synchronize to the cloud. The cloud will send email off to that user. They will accept or decline this through a common web page, and then they will have access to the data. So finally, when you want to access this data offline from a WPF app or any rich client app of your choice, you're going to leverage the symmetrical APIs. So this is as simple as changing the connect method. As we showed earlier, you switch from a connect with credentials up to the cloud to doing a connect local. At that point, you can see the full set of resources that are available on the client. Any changes that you make are synchronized up to the cloud in the background for you. In the WPF app that we had earlier, it presented a page on startup, which listed the set of message boards and the set of contacts. This is the code that did that. New live operating environment is connect, where connect would actually do the connect call itself with password from a configuration file. Then it would read the contacts, and then it would get all the message boards. That's all there was to that client app. So if it made changes, those additionally would simply be writing the data entries back and updating that feed. And that's it. There's nothing else that's needed. So as I mentioned in the beginning, there were 3 key things we wanted you to take away. That LiveFX was the uniform way to program the live services from whatever platform or device or application you were comfortable in. That it was a great bridge to software and services, so you could get the benefits of both, and that there was a .NET library available to you today. So this is part of the SDK. We'd really like your feedback. It's early. There are a bunch of related sessions here that go into more detail than I did today. The lap around was done earlier today with Ori. He's a fantastic speaker. I'd recommend that you check that out on video. Don has built the first mesh application that does some really intricate list work of different sorting queries and binding the presentation UI. And he's worked through those problems and has a bunch of best practices for you. Tomorrow morning, BB119 is a deeper look at the architecture and some of the insights. So we barely touched on the resource scripts and how to program some of the more complicated parts of the endpoint. So that's a great talk for that. The other one I'll call out is BB30. Tomorrow afternoon, there's a talk about building mesh-enabled applications, or mesh-enabled web applications. These are the ones that you can publish to the cloud and take offline. So all I've done today is touch on the periphery from the rich client and from the web client. And now you'll have the same set of APIs available to you in the hosted applications. And finally, if you want more details on the notification infrastructure, the awareness infrastructure, and communications for P2P, there's a talk again on Thursday, I believe. Mandatory reminder to fill out your evaluation. Q&A. Before we begin Q&A, I'll also mention the live services group is hosting a happy hour at the Westin, so you're all invited to continue the Q&A there. Thank you.
So you showed us how you can do application-controlled security on data types. How do you do IT security control of mesh apps? And because it's great that I have to invite the other person, but what if the person I'm inviting in is a bad guy? And and honestly, I've been playing around with this for a while, and I have internally, and I've seriously compromised my corporate network, very seriously.
So what was the question? How do you
control mesh apps from an IT perspective?
Oh, from an IT. Sorry, that's the part I didn't get. So at this point, I would say we have very crude controls, and this is an early CTP, so we would welcome feedback on that. As an example of what we've done is we've started to implement group policy on things like remote desktop, which was one of the top IT concerns, so that you can require that that two-factor auth is enabled for you to connect into an enterprise. You could also block functionality like that if necessary. So for applications, you could consider only allowing applications from identities that were within the enterprise. You could, or only had access to resources on devices that were in the enterprise.
But are you looking to provide the same type of, for instance, signing mechanism that you have in Windows apps, so that I could prevent by policy the installation of applications that aren't signed with known certificates?
We would happily consider it. What you have today is Mesh Apps is the very first application model that we're pushing through the live framework.
I understand.
And I expect there will be many more. And that's good
I understand. It's just I played with this and I scared myself.
If I send an invite to somebody that's on a Unix or a Linux system, will they be able to play and join in, or what?
Certainly.
Okay.
The website is available on any platform. The mesh-enabled web applications are available on that platform, and the HTTP endpoint is there. We don't have a client library for them to experiment with, but they could certainly talk directly to the protocols.
Okay, thank you.
There's a ton of stuff there. I guess I'll try and narrow it down to two quick questions. First of all, will you guys have tokens at happy hour?
Well, we give out tokens. I know there were some left. Yes, the fellow with his hand raised in the back, he will be the Pied Piper.
So the best option to get tokens is come by, do one hands-on lab on the mesh, and I'll give you a token tomorrow.
All right, great. That was an easy one. What is the relationship between the mesh data entries and the actually Azure storage services? Is it just a level of abstraction, or is it something totally different?
No, there's a pretty good connection. As we talk, actually, we're migrating some of our data, certainly the new data, to the Azure storage services. So they are the low-level blob and metadata storage.
Okay.
We have user scope data that sits on top of that, that's synchronized. And so ours is, basically it is user scoped, and it's the synchronization functionality. But we will use them as the base going forward.
Okay, so is there, and certainly I can table this for later if it's coming up, but is there, if I have already objects in the storage services that don't have the user scoped metadata around it, is that something that I can capture and present, or does it have to be done through the live operating environment? So I've already got all the stuff, right?
Yep.
Call it 10 gigs of stuff. I want to represent it with the extra attributes that you were talking about.
Are you a user or an application developer in this case?
I'm an application developer who wants to represent that to my users.
Okay. So. Today, we only expose data that's in the live services through our endpoint. It's possible to synchronize that data or to federate that going forward. We don't have any plans in that today, but it would be interesting to follow up on afterwards.
So essentially it'd have to recreate it
Yep.
with the, okay, great, thanks.
Or you could also link to it effectively. You could publish metadata about that if you wanted, and
okay.
expose
Great.
it that way.
Thank you.
Hi. Similar to what the other gentleman was asking about users, does a user have to have a Windows Live ID?
Yes, today a user does have to have a Windows Live ID.
Okay. So is that going to change, or is that I mean, let's say I want to bring a user in and there's some other type of authentication system or authority that defines who they are, or some identity system.
The expectation, at least for the near term, is that they would need a Live ID or a federated identity with Live ID.
Okay. So if a federated one would mean they would still have to have, they could have a different identity system could identify them, but it would have to be associated with the Windows Live ID, or how does that work?
I would recommend for this one that we talk to some of the Live ID guys down in the pavilion afterwards for the details on what they'll roll out.
Okay.
Are you planning to integrate with Geneva then?
I don't have an answer for you on that right now.
Okay. One small question. You talked about the data feed object. Is JSON used at all under the covers there, or is it all Atom?
You can think of the data itself as an abstract info set,
Okay.
and it doesn't really matter how we persist it. We can
Okay.
transform it between the different representations on the fly as the application needs.
Okay, great. Thanks.
I have two quick questions. One, when you have a mesh object, what's the story for updating your mesh objects? Let's say you have an application, it's out there running, you update that, but you've modified, changed some of your mesh objects. How does it handle those type of conflicts? Maybe in the wild, during the upgrade process, you've got both applications running.
So today, you have the opportunity to publish a second version of your application. When you publish that second version, we've put the burden on the application developer to interpret the data from the prior version. So I realize that's not the best solution, and it puts a little bit too much effort on your plate. I'd be interested in hearing common patterns from you on how we can improve that and do some of that for you.
Well, that goes into my next question, which is when you see the live mesh icon, it says add to my mesh. What if we have a community portal, and it'd be great if people we could push updates of things they've been posting on or conversation threads they're tracking, into like live mesh. How would that work? Would I have to build a new live mesh from scratch? Or is there objects in there I could reuse, like the news object, or am I not allowed to do that?
No, you're definitely allowed to do that, but with the user's permission. So the expectation is that you'd want to publish or consume news entries if that's the entity that's of interest between your site and the mesh site. So you could imagine bridging social networking sites and being able to cross-publish events for those. So that's something that could be supported. We don't have all of the infrastructure in place exposed for that, but you do have access to the news feeds within a mesh object. What we would need to do is make it a little bit simpler.
Okay, but I could do that today with what you have. I could get their permission and push changes they're making in our system into their live mesh, like notifications and news.
Yes.
Okay, thank you very much.
You're welcome.
Did I see an apps link on your live desktop,
You did.
which I don't have?
You don't have it yet.
Okay, is that coming soon?
It is in the developer sandbox right now. And so the applications are definitely in CTP phase. We want to figure out if this is the right model for applications and if they meet developer expectations. Once we have a handle on that, we will publish that for users. So you have to sign up for the developer portal at this point to experiment with it.
Sure, thanks.
You were first, go ahead.
In the sample application, you created the mesh board. So you had your own data feed type, right?
That's correct.
And mesh, as I understand it today, currently does synchronization with file system objects, right? How do you sort of inject your own data storage, if you will, in there so that I don't want to just have, some metadata properties on the data folder or whatever, but I actually want to have, binary blobs associated, but I want to store those binary blobs in a database or, somewhere else.
Mm-hmm. So there's probably one limitation that you'd hit today, but let me explain how the system works first. For each endpoint, you're synchronizing both metadata and blobs between those. If the feed has a particular characteristic, file system handler type, then you basically have an application called the live mesh folder application that runs on the client that realizes those blobs into the file system. It's also responsible for watching for changes to those blobs and publishing them back into the mesh. So it's somewhat distinct from the actual synchronization technology. So in your case, rather than the file system being a separate component that you want to synchronize with, it could be a database. And in that case, you'd want to pull the feed sync feeds so that you had true feed sync capability, history, tombstones, et cetera, and fetch the enclosures from the endpoint and pull them into the database, and vice versa, cross-publish them back out. Now, the one caveat I mentioned is that today we'll always persist those enclosures in the file system in terms of temporary storage. So you don't have the opportunity to put them directly in your database from the endpoint. If you talk to the cloud, you could do that yourself, but if you wanted to do it locally, then there is that intermediate step.
Okay. And do I plug into that mechanism through the notification process then, or I'm a little, maybe this is a little too technical, but.
Well, I'm happy to follow up afterwards, but if it's a feed that contains blobs, it has feed sync entries, you can subscribe to changes on that feed. As they come in, you would look at those, you'd fetch the enclosure, put it in the database. Vice versa, you would just publish an entry or an update whenever.
Okay, thanks.
Thank you.
I had a question about the authentication. Like when I installed the Mesh desktop client, there's a notification area icon. I right-click on that. I sign with the credentials I want. If I'm running an application and I just want to connect locally, is there any way to reuse that authentication since the user has technically already signed in, or do you really require each application to ask for that login information?
It's an interesting question. Today, once the user signs in, all the rich client applications running in that user session actually interact as that user, and they would have to override with a different set of credentials to get different access. And the interesting question is whether applications should always authenticate or whether they should always operate, what the default is for those two. But so the answer to your question is yes, you do have access to the current logged in user's data today.
Okay, thanks.
You're welcome. Thank you very much.